Welcome back to my channel. Today I am going to talk about approach to AI. In previous classes we have discussed about the first one, the first approach, that is acting humanly, the Turing test approach. Now in this video I am going to talk about thinking humanly, that is the cognitive modeling approach. Now let us see what is this is exactly. If we are going to say that a given program think like human, we must have some way of determining how human think. We need to get inside the actual working of human minds. There are three ways to do this: through introspection, trying to catch our own thought as they go by; through psychological experiment, observing a person in action; through brain imaging, observing the brain in action. Once we have sufficiently precise theory of the mind, it becomes possible to express the theory as a computer program. If the program input and output behavior matches the corresponding human behavior, that is evident that some of the program mechanism could also be operating in human. For example, Alan Newell and Herbert Simon, who developed GPS, the general problem solver. Newell and Simon in 1961 were not content merely to have their own program solve problems correctly. They were more concerned with comparing the trace of its reasoning step to trace of human subject solving the same program. The interdisciplinary field of cognitive science brings together computer model from AI and experimental techniques from psychology to construct a precise and testable theory of human mind. Cognitive science is a fascinating field in itself, worthy of several textbooks and at least one encyclopedia. Wilson and Kale in 1919. We will occasionally comment on similarities or differences between AI techniques and human cognition. Real cognitive science, however, is necessarily based on experimental investigation of actual humans and animals. We will leave that for other books, as we assume the reader has only a computer for experimentation. In the early days of AI, there was often a confusion between the approaches. An author would argue that an algorithm performs well on a task and that it is therefore a good model of a human performance, or vice versa. Modern authors separate the two kinds of claim. This distinction has allowed both AI and cognitive science to develop more rapidly. The two fields continue to fertilize each other, most notably in computer vision, which incorporates a neuropsychological evidence into computational models. This is all about thinking humanly, that is cognitive modeling approach. Now we will talk about another approach to AI, that is thinking rationally, the law of thought approach. The Greek philosopher Aristotle was one of the first to attempt to codify right thinking, that is, irrefutable reasoning process. His syllogism provided a pattern for argument structure that always yielded a correct conclusion when given correct premises. For example, Socrates is a man. All men are mortal. Therefore, Socrates is mortal. These laws of thought were supposed to govern the operation of the mind. Their study initiated the field called logic. Logicians in the 19th century, excuse me, yes, now we will start with my topic, that is thinking rationally, the law of thought approach. Logicians in the 19th century developed a precise notation for statements about all kinds of objects in the world and the relation among them. Contrast this with ordinary arithmetic notation, which provides only for statement about numbers. By 1965, a program existed that could in principle solve any solvable problem described in a logical notation. Although, if no solution exists, the program might loop forever. The so-called logicist tradition within artificial intelligence hopes to build on such program to create intelligent system. There are two main obstacles to this approach. First, it is not easy to take informal knowledge and state it in the formal term required by logical notation, particularly when the knowledge is less than 100% certain. Second, there is a big differences between solving problem in principle and solving it in a practice. Even a problems with just a few hundred facts can exhaust the computational resources of any computer unless it has some guidance as to which reasoning steps to try first. Although both of these obstacles apply to any attempt to build computational reasoning system, they appeared first in the logicist tradition. Now we proceed further to another approach to AI, that is acting rationally, the rational agent approach. An agent is just something that act. Of course, all the computer programs do something, but computer agents are expected to do more, operate autonomously, perceive their environment, persist over a prolonged time period, adapt to change, and create and pursue goal. A rational agent is one that acts so as to achieve the best outcomes, or when there is a uncertainty, the best expected outcome. In the law of thought approach to AI, the emphasis was on a correct inferences. Making correct inferences is sometimes a part of being a rational agent, because one way to act rationally is to reason logically to the conclusion that a given action will achieve one goal, and then to act on that conclusion. On the other hand, correct inferences is not all of rationality. In some situation, there is no probably correct thing to do. But but something must still be done. There are also a way of acting rationally that cannot be said to involve inferences. For example, recoiling from a hot stove is a reflex action that is usually more successful then a slower action taken after careful deliberation. All the skills needed for the Turing test also allow an agent to act rationally. Knowledge representation and reasoning enable agent to reach good decision. We need to able to generate comprehensible sentences in natural language to get by in a complex society. We need learning not only for erudition but also because it's improve our ability to generate effective behavior. The rational agent approach has two advantages over the other approach. First, it is more general than the law of thought approach because correct inferences is just one of several possible mechanisms for achieving rationality. Second, it is more amenable to scientific development than our approaches based on a human behavior or human thought. The standard of rationality is mathematically well defined and completely general and can be unpacked to generate agent design that probably achieve it. A human behavior, on other hand, it is well adapted for one specific environment and is defined by a will, the sum total of all the things that a human do. This book, therefore, concentrates on a general principle of rational agent and on a component of constructing them. We will see that despite the apparent simplicity with which the problem can be stated, an enormous variety of issues come up when we try to solve it. We will see before too long that achieving a perfect rationality, always doing the right thing, is not feasible in complicated environment. The working hypothesis that perfect rationality is a good starting point for analysis. It simplifies the problems and provide the appropriate setting for most of the foundational material in the field. We will see chapter 5 and 17 deal explicitly with the issue of limited rationality. Acting appropriately when there is not enough time to do all the computational one might like. Thank you so much for listening this lecture, that is approach to AI. Thank you.